So I want to look into all the reverse engineering patterns here. Okay. So I want to start a delivery business. Okay. I will see the pattern of Swiggy. I want to compete with Swiggy and Zomato. Okay. So the packet is being delivered to me. What is the cost here? So let's say I am ordering some masala dosa. So I am getting it. I will see the price there first. What is the price that I am getting? Then what I will do, how much the raw content, what is the actual uh, uh, material it exists. Okay, how much it costs? Let's say this will cost around some 12 rupees. Max it will cost 12 rupees. Let's say I will put labor 8 rupees. Okay, then real estate, that business whatever, I will put 1 rupee. Okay, 21 rupees it costed, the actual raw material. So then this guy, whoever has delivered me, he charged me for 160 or 170 rupees for dosa. Okay, let's say I will give 40 rupees to this delivery guy. Okay, from 150 it got reduced to 110. So then from 110, now restaurant charges around 30 rupees profit. So now it goes to 80 rupees. Now Swiggy will charge 20 rupees. Then it will go to 60 rupees. Okay. So now how you are calculating? You are just decoding all the business now. So you are doing it in a reverse manner. So now you will get, okay, how much the dosa cost. Okay. So then in the dosa again you are filtering it out. What is the batter that he has used it? Is it ghee or normal oil? What are the ingredients? Does he kept any cashews there? All that you are calculating in reverse way. Now you will understand the business. That is how reverse engineering is done in every field, not only in software. You do it in every aspect to figure it out how things will work. Okay, wherever there is a, you don't have anything concurrent with you. Okay, you don't have any knowledge. Okay, I was just curious. In my childhood also I used to open lot of electronic items. I want to see how that works. That is called reverse engineering. Here also in our we have software, in software computer science, you will have binary reversing. Okay, where you will be disassembling the compiled executable file, like it is in exe or elf or dll, into an assembly language or decompiling it into a code to understand this logic, how it is written, how it is executed. Based on that you will understand it. Okay, so for malware analysis also you will do it. Static analysis you will be doing, like you will disassemble all the code, and you will do a dynamic analysis as well. Dynamic is you are going to run it on a sandbox. Okay, like you want to execute it to understand what exactly it will do. You want to check the payload, where it is impacting, or you want to see command center where it is executing. So you want to see how the evasion techniques are, like how it is going to camouflage its presence. So all these you are trying to analyze from a malware analyst part. Okay, now you want to do some protocol reversing. So in earlier this one, there is one movie. Okay, during World War II, they used to transmit the codes here, like when they are going to attack, how they are going to attack. So you will have some movie there. Okay, I don't remember that movie. So that is like you are reversing that protocols, how your communication is working. You are intercepting and decoding your network protocols. When specifications, how it is working, it is not being published or it is not public. Okay, so you will be often using the proxies or packet sniffers. Okay, then you have library reversing. You will extract the functions or signature, how it is being called here. Okay, and then firmware reversing. So like there are a lot of things. I don't want to go into all other aspects. Let's start with reverse engineering in our software related. We'll go by definition. What is the core concept here in reverse engineering? Okay, so you are analyzing a process which is running it, okay, or a piece of software which is executable. So you will not have any source code available. So how it is run, you don't know. Okay, I am going to give you a suite. Okay, you need to tell me whether this is veg or non-veg. So you will get puzzled. Okay, how come you are giving me sweet and you are asking me whether it is vegetarian or non-vegetarian? Okay, you don't know the recipe there. Similarly, here you just have an executable code and you don't know how that is built. Okay, so now you want to figure it out how that is built. Okay, you want to figure it out how it is internally working. So that is called reverse engineering. Okay, so China got these Tesla cars. Okay, they imported 1 or 2 cars. Okay, so within a year or 2 years, they done a reverse engineering and all the market they took it over. Okay, and do you know the Lucknow locks? You know locks like 7 lever locks, where Lucknow was famous once upon a time. Do you remember that? We have old locks. They got to know how these will work, all the mechanism, everything. They understood the mechanism. Okay, how these 7 levers will work, all that. Okay, after that, what they done? They went to China. Okay, now they created this. Okay, they done. Okay, now we are going to create this. We understood how you are going to do. Now you take our locks. Okay, this is how we will create the locks now. Now you take it, made in China now. So we are going to give this to you. Just you put it. So you just tilt it. That will get opened here. So what they done? They opened the source code. These Lucknow people, they told that how it is going to work. Okay. Source code was available for these guys to manufacture. So if you are not giving how it is going to work, so they will split into two pieces. Okay. Literally they will split into two pieces and they will see how that is going to work. Okay. And one more thing is, one more example I will give. I was very curious and fascinated about the Salarjung Museum. Okay, have you heard that Salarjung Museum? People from Andhra, they would be, they will know. Yeah, Pawan, have you visited this? Okay. So there we have a lock there. Okay. There is a lock where for every hour one guy cartoon will come, okay, and he will ring the bell and he will go inside. So if it is 1 o'clock, he will come and he will just hit ring bell at one time and then he will go inside. If it is 2 o'clock, then he will come and hit 2 o'clock, the door will open and he will hit for 12 times. Okay. So lot of scientists told, okay, we want to open and see. Government strictly warned nobody is going to touch that clock, because they want to do a reverse engineering how it going to work. Okay. So still till now no one cracked it how it's work. So at 12 o'clock a cartoon will come, okay, and it will ring the bell. It will take hammer and it will hit for 12 times to this bell. Okay. So they wanted to do a reverse engineering. I want to see how it works. Okay. If they open, it will not work. Okay. So this is all about reverse engineering. Okay. And in our example, instead of starting from requirement and writing code, so you will just decompile it and you will see how this is working in a backward manner, from raw bytes to instruction, then logic, and what is the intended here. Okay. So that is how you will be doing this. So you take the compiled code, you will open in the disassembler, you will see the listing there, how it works, then you will do it decompiler, then you will see that pseudo code there, how things are working. Okay. The ultimate goal is to understand the behavior or the data structure, how and what, based on that logic you are going to see that without knowing how it is written. So that is called reverse engineering. So our motivation in reverse engineering is we want to do the analysis part, how that is going to work. Okay. So why it will work? So we want to understand the analysis of the malware, how it is going to work, what is the what is the objective of the malware. Okay. So what exactly the malware does, how it is going to do. So we want to do the detection part. So where it going to reside. So you want to catch a mice, then you will see, okay, this is the mice trap, you will put some cheese and you want to capture it. So you want to do the same thing for cockroach, so that will not work. You want to do the same thing for ants, whatever you are doing it for cockroaches, that will not work. So you want to understand first what is the type of malware you are doing it. Okay. So based on the statistics and the um, behavior, you will see how the malware is going to be categorized based on the family. Okay. So you will check whether do you have any compatible tools or drivers, file format. You want to document it or you want to analyze that. So that is why you will be doing it for a reverse engineering. So you got to know now what is the key role in reverse engineering. Okay. Sorry. If you see lot of the AI tools that are coming from Chinese, okay, so all they are just pulling it from the main tools. Okay, you got the DeepSeek there. Okay, so it got all the response now from ChatGPT and then Claude. So if I give one response, what is that output that I will get? So I am going to do all that ping pong. Once I am done with that, now I know how you will talk. Okay. So if I tell you, okay, I am going to use you, then it will give one response. So I will give, okay, I am going to abuse you, then it will give one response. I want to help you, then it will give one response. So based on all these responses, they will capture the behavior, how it is programmed. Okay. So that is how once they have built it, now they have made that open source. Now you see the DeepSeek. You don't have to pay anything. This is open source. You build it yourself. Our intention is just to make sure that you lost the business. You don't have to earn money. That is the only intention that we have. Okay. So the in the process, how it is going to work, reverse engineering flow. First you will acquire and identify. You will get a sample and then the file format and then a compiler. Okay. Then you will open that particular file. You will do a static triage here. So what exactly you have, where it is importing, what is the hash file of that, how it is packed, what exactly it is doing, all that you will do that deep analysis. You are not running anything, you just opened it. Okay. So you opened that file into a decompiler and you are analyzing that. Okay. So if you open your Flare VM, you will get all these tools like editors. Okay. So then you will do some static analysis. You are going to disassemble and decompile to map the logic. Okay. So you are not running it. Without running, you are doing all this. Now you done a static analysis. Okay. You have done a static analysis. Now you want to execute. Okay. Now you need to do, okay, you want to execute, okay, you come and execute it. Let me see what exactly you will do it. Okay, I will give you a chance. Like film heroes will tell, no? Okay, you come and hit me. I will handle it myself. So now you are going to do the same thing. Okay, in dynamic analysis, you will execute it in a sandbox. Okay, and you will see that the real behavior, how it will work. Okay, you will allow it to run. You want to see what exactly this is going to do. Okay, so once you document it, you will see the findings there. Okay, what exactly this is doing. So you will report and remediate it. So these are the workflow that how you are going to manage it. So at least if you do one malware analysis, then you will come to know how these things will work. Okay. So now we have two approaches here. One is static analysis, the other one is dynamic analysis. Static analysis, you are not going to run anything. You will just analyze it with the code. So how you are going to, how it is running, where it is running, where it is hiding, all that you will collect that information in the static analysis. Code never runs. In a single line, you will tell it is not going to run anywhere. You will just see it and you will disassemble that. So in dynamic analysis, you will just execute it. Okay. Like you are going to give a sword to villain. Okay. So I also have a sword now. Let's fight. So here you are allowing the code to get executed in a controlled environment, in a debugger or a sandbox. Okay. You want to see where exactly this is running, how the memory, what exactly this is doing in memory and what it is calling, where it is residing. So you are going to watch that file, registry and network activity, where exactly this is contacting, what exactly this is doing in the network. Okay. So it is going to reveal runtime only or packed behavior. So you will see once this run, what exactly this is going to do, how it will be doing a behavior. So how steps are being done. Okay. So it will require a isolation. So you cannot run that on your system or server. You need to have a complete isolated environment. In static analysis, you will just open up in the disassembler and you will analyze this. So you will have a limited exposure here. Okay. So if it is packed, okay, only if you run, then only I will open. Then static analysis will not work. Let's say you have a parcel. Inside that, there is one more packed parcel. Like you ordered an iPhone. Okay. So what Amazon will do? Let's say Amazon will pack it in one layer. Okay. Inside that, Apple has packed it one more extra layer. Even if they tampered the Amazon packet, they should not be able to get it through that particular Apple package. So they would have done it. So if it is tampered, then you return this packet or package. Similarly, here in static analysis also, so if some viruses, what they will do, so if they open up, if they are not running, you just show them there is nothing hidden here. If they run, then only you unpack it. So this is all about static and dynamic analysis. So in static analysis, you will open up in the disassembly here. So raw machine code into readable assembly instructions like IDA Pro or Ghidra. Okay, I want you to open Ghidra tool. So you will not have better understanding on the on this tool, because you will not know the instructions there, but it will be you can open one exe file without executing. Okay, I will open up uh, Flare VM. You can see that IDA Pro or Ghidra. Now I am opening tools here uh, in Flare VM. So you want to analyze any software, or you want to do any reverse engineering. So you will open up in the debuggers and you will analyze that particular code here. So let me search it for Ghidra here, where this is hidden here. I'm not getting it. I will open up with this. I can see that there are a lot of Ghidra entries. Okay. So let me see. There is the executionable file here. So you have Ghidra here. This is the icon. So you can open up that in this file. Text editors. Debuggers. Okay. Utilities. Not utilities. Utility. Category utilities, productivity. You have it here in others. Okay, this is Ghidra. Okay. So what you do, you just open up file here. So it is hashing. So let's say this is a virus file. Okay, this is not a virus file. This is Notepad++. Okay, so you want to see how it works. You see the format is portable executable here. This is showing me destination folder, all that. Okay, I will click OK. Now it is importing that particular file. So it is analyzing the file here. Okay. It is loading all the required files. So now you got all the details here, summary details, everything. Okay. So compiler here, Visual Studio. So it created date, today's date, all this format. So you see that PE property file description. This is Notepad++ file. This is hash file, MD5 sum. And this is checking where exactly all these paths it is trying to access. Searching path for library, DBG help, DLL. You are getting all these code here, you want to analyze it. So that in the summary it has given us where exactly this is executed at the memory location, all that it has given the information. So now you are seeing this, what are the headers, what is .txt, okay, what is the R data here, what is the data inside this, then .p data. So you are going to see it and analyze this. This is the memory location, okay, where this is running, okay, what it is importing. Okay, you see all these libraries it is importing. So what it is exporting into the system or files, okay, what are the functions that it is trying to run. Okay. So data types. So if you know a little bit about assembly language or on the data stack, then you will look into all these aspects, how you are going to run that particular area, you see. So this is your memory map. So from this location to this location in RAM, this is reading, okay. So .text, it is read and executable, okay. And you have .data, read and write, this is doing at this memory location. So from this area to this area, this is going to write, okay, in RAM. This is how it is accessing it here. Okay. So I don't want to go into complete details, or else you will tell, okay, we don't want this. Okay. So this is where you will be analyzing lot of stuff about the virus behavior, all that. For this, if you are into threat hunting, okay, or you want to develop the solution for antivirus, or you are a hardcore programmer, then knowing all this will help you. Okay, we just wanted to know how you can open that file without executing anything. Okay, this will help us to analyze what exactly it is trying to access, where it is accessing, how it is executing, all that we can see. Okay, so one or two will see that virus files. So then you will know how to do the decompiling of that in the dissembler here. Okay. So this is your Ghidra tool, okay, where you will be opening up that particular file and you are analyzing. So this is nothing but Notepad++. I am executing this. You can say this is a dynamic analysis now. So this is nothing wrong with the exe here. This is Notepad++. It's not a suspicious file. So I wanted to know whether this will be marked as suspicious, all that. So we wanted to see it. So this is a normal file. So if you have a virus file, then you can go inside that and you can try to figure it out what exactly this is doing. Okay. So now we'll come back to our slide here. Okay. So you will be doing this disassembly. Okay. You do IDEA Pro or Ghidra. So you will get all the readable assembly instructions. So this is how you will get all these instructions here. So then once you do that, you will see where it is getting connected, what exactly this is doing. You can see this with all the tools here. Okay. So it will take time consuming. That's why I don't want to do drill down into complete analysis of that tool. Okay. Then we have dynamic analysis. So you what you do in dynamic analysis, you allow it to run. Okay, let it run. Okay, we will see it with based on the behavior, how it is contacting, how it is trying to run, where it is running, why it is connecting. All that you will see. If you see this example here, behavior underscore trace here. So you have a file or you done an analysis. It created a file PID2044. Okay. So then it accessing the registry here. Now it is trying to connect, okay, to a command control over a secure channel. Okay, through HTTPS it is trying to connect. Now it is doing some virtual allocation. So I want to reside in memory. So can you give me some space in RAM? So I will be executing there. So it will open up and it will just inject into explorer.exe so that it keep on running. Okay, that's how you will be tracing this or doing a dynamic techniques. Okay. So you will allow it to run. After that you are going to capture what the behavior is all about. Okay. So now we will see the landscape here. What are the tooling and landscape? So one tool we have used it here, that is your Ghidra. Okay. So I will color this. Don't have coloring here. Just saw this. Okay. So then you have IDEA Pro and Binary Ninja. Let me see if we have Binary Ninja in our tools. You don't have this Binary Ninja. So dynamic sandboxing, you are going to do it with Wireshark, or these tools also we have done. PEBear and then WinDBG, GDB, you can do with these are the debuggers. Okay, Wireshark will do it for network analysis. Kaku will see whether we have that. So we don't have that tool either. So this is where you will be using it for reverse engineering. Okay. So now malware analysis, special case here, behavior versus code analysis. So behavior analysis will do, okay, what exactly this is being done, okay, what did it do? So it executed, what exactly happened? That is what behavior will tell. Let's say this is uh, creating temporary files. Let's say that is the behavior. Let's say this is going to occupy memory. That's it. Nothing, it is doing nothing. So let's say this is deleting files, or else this is rising the CPU temperature. So what is the behavior? Okay, then code level analysis, uh, what the code will decide. Let's say you have a logic bomb. Okay, on every Sunday this needs to be executed. So every day you are opening it, nothing is happening there. Only on Sundays this will get violent. Okay, because the code is returned like that. Okay, uh, so this is how it will be deciding. So you will analyze the code, what the code is being written, how it is written. Okay, so then your IOC extraction. So what it is compromise and it is doing that extraction here. So is it pulling any IP address or domain or registry keys? Indicator of compromise. IOC is like, so if you access this, then we will indicate like, so the system is compromised. Okay, so based on this information you will know, okay, what exactly this is trying to send the information. So then packing and obfuscation means how it is hidden, how it is packaged. So people will children will do hide and seek, right? They will play. So how is it going to do a obfuscation here, so that you will be not able to read that particular file. So I will read that malware authors compress, encrypt or scramble code to resist analysis. Unpacking it is often the hardest step. Okay, so you have delivered the package, but it is completely unpacked. Packed it. Okay. So even after opening, you got one small gift. Let's say you have duck inside. Okay. Inside duck there is a recorder or there is a hidden camera. Okay, which will be automatically running, and you need to put it to a charging there. Okay. So every 1 week, weekly once you need to charge that. But inside you have a hidden camera there. Okay, so that is the example of obfuscation. Okay, so you are packing it, you are hiding it, so that even if you analyze also, you should not be able to see what exactly inside that. Then you have boundaries, legal boundaries and ethical consideration. So you are going to not reverse any software are you of your own. Okay, so are you licensed to test it, or do you have any permission from the vendor? So I have shown you that Microsoft will tell you are not authorized to do reverse engineering of my product. You are authorized to only use it. So you are not the owner. So all that you will have this legal consideration. So even if you are discovering it, you are reporting this vulnerability to the vendor first. You need to tell them, you need to ask permission before you are publishing it publicly. So let's say you found out a bug in Windows 11. So you will inform the first vendor, like Microsoft we will inform. So they will appreciate, okay, very good, we will appreciate it. Please do not post that in any websites. So they will take enough time. So once they patch that particular loophole, then they will ask you to publish. Okay, you can go ahead and publish that. Then if you want to run it or you want to study it, so you need to do it in a sandboxed environment or a isolated VM environment. Okay, these are the ethical and legal considerations. So if you want to learn reverse engineering skills, so you can practice on crackmis and CTF. Okay, so these are the available tools online. Then you can get a dissembler. So you can go with Gidra, okay, or IDA free, where you can analyze lot of stuff here, or you can go ahead with the books like Practical Malware Analysis, and you can join the communities also. So if you want, I can get you this file, Practical Malware Analysis, then you can study it. That's it all about your reverse engineering part. So that is the software engineering